Hi, this is MD Shabana Sultana, working as Associate Professor in the Chapter Engineering College. Today I want to discuss about some of the important compounds in the thermoplastic and thermoset plastic resins. In the last lecture, I explained about the polyvinyl chloride. And in this, I want to discuss about the important compound, that is the Bakelite. So this Bakelite, it is an example of the thermoset plastic resin, which is named after the scientist Bakelite, who synthesized this resin in the year 1909. This is the structure of the Bakelite. And coming to the preparation, it is prepared by the stepwise polymerization, or it is also known as condensation polymerization, in which is a slow steps. That means the reaction does not take place spontaneously at a time. It takes place in the stepwise manner. And the starting material, the preparation of the Bakelite is, it is a phenol and the formaldehyde. It is prepared in the presence of an acid or an alkali as a catalyst. And the polymerization takes place in the three-step mechanism, or it takes place in 3 stages. First stage, the phenol is made to react with the formaldehyde in the presence of an acid or alkali, and it forms mono, di, or tri-phenols, methyl phenols, depending upon the phenol-formaldehyde ratio. Depending upon phenol-formaldehyde ratio. If the phenyl and formaldehyde is in the ratio of 1:1, it will get only monomethylol phenol. That means only one substituted will be there if the phenol and formaldehyde is in the ratio of 1:1. Or if the phenol and formaldehyde is in the ratio of 1:2, that means 1 part of the phenol and 2 parts of the formaldehyde, then 2 substituted, that is disubstituted methyl phenol will form. Suppose if we take this formaldehyde ratio as 3% and the phenol is only 1%, then trimethylol phenol will be formed. That means that this substitution will be in the 3 positions because the ratio of the formaldehyde is more, that is 3 parts. So this is called trimethylol phenol. Trimethylol phenol will be formed if it is taken in the ratio of 1:3. I'm taking this 1:3 ratio product for the preparation of the Bakelite. So this is the first step. Second step, this trimethylol phenol, if it is heated to produce, it also 2 products are formed if it is heated. And 1 product I am taking, which on this product is known as Novalc or resitol. This, when treated with the phenol, it forms this polymeric chain, which on further treated with the formaldehyde, and it is heated in the presence of heated, the water molecule will be removed. Like this, the chain continues and forms a cross-linked solid called Bakelite. Cross-linked solid called Bakelite will be formed. This is the structure of NOVAL, which is the which is the intermediate product which is formed in the second step. And this is called the resolve. I already told you in the second stage, two products will be formed if it is heated. One is a NOVA and another is a resolve. Coming to the uses of Bakelite. Bakelite is used widely for making the electrical insulating parts like the switches, switchboards, and the handles of the heaters. And it is also used for making the molded articles like telephone parts, cabinets, and phonograph records. Electrical switches and bearings used in the propeller shaft in the paper industry, and is also used as a ion exchanger in the water purification by our ion exchange method in boilers. It is also used as an adhesive for grinding wheels. It is also used as a sulfonated bakelite as an ion exchange resin. It is also used for impregnating fabrics, wood and paper. It is also used, this bakelite is also used in the paints and varnishes. And the best application of the bakelite is also used in the tarpaulins, wood laminates and the glass laminates. And it is also used for making the bearings used in the propeller shaft, that is in the paper industry, and it is also used in the rolling mills. So this is about the applications or the uses of the bakelite. Coming to the properties of the bakelite. Bakelite plastic resins is a hard, rigid and strong, and it is a scratch resistance and water resistant polymer. And bakelite, it is having a good chemical resistant, that is resistant to acids, salts, and many other organic solvents. But it is attacked by the alkalis due to the presence of OH groups. See, the OH groups are present in the structure of the bakelite. Because of the presence of this OH groups, it is easily attacked by the alkali. And it acts as a very good ion exchange resins. That means it exchanges the OH group with another anions. And it has a very good, excellent electrical insulating property. And it is a very good adhesive. And it is having a very good corrosion resistant, that is resistant to atmospheric conditions like oxygen, carbon dioxide, moisture, light, and UV radiations. So this is about the thermoset plastic resin example. Coming to the next example, that is a polycarbonates. So this polycarbonates, these are the group of thermoplastic resins containing the carbonate group in a chemical structure. This is a carbonate group. It is having the carbonate group in the chemical structure, and it is also having the epoxy linkage. COO. Epoxy linkages is also there in the structure. So this is a repeating chemical structure or unit of polycarbonate made from bisphenol A. Bisphenol A. Coming to the structure of the polycarbonates, it received the name because they are having the polymer containing the carbonate group. And most polycarbonates of commercial interest are derived from the rigid monomers. The important useful features are it is having the temperature resistance, impact resistance, and optical property of the position of the polycarbonates between commodity plastics and engineering plastic. That means the position of the polycarbonate can be kept between the normal plastics and engineering plastic materials. So it is having this carbonate group and the epoxy group are present in the polycarbonate structure. Coming to the preparation or the synthesis of the polycarbonate, the polycarbonate plastic resin is produced by the reaction of bisphenol and phosgene. See, this is a phosgene structure. COCl2 is a structure of phosgene. It undergoes polymerization and forms the polycarbonate. See here, bisphenol and phosgene combined together. The first step involves the treatment of the bisphenol with sodium hydroxide. This is a structure of bisphenol A, and it is made to react with the base, sodium hydroxide, which undergo deprotonation. Deprotonation means removal of the proton and hydroxyl group. The hydroxyl group of the bisphenol will be removed and forms this intermediate called diphenoxide. This intermediate is called diphenoxide, which is made to react with the phosgene. This is a diphenoxide structure which acts as an intermediate, and it is made to react with the phosgene to give chloroformate. Chloroformate, which subsequently attacked by another phenoxide. This is one phenoxide. The product which is obtained by the reaction with the phosgene, and it is attacked with another phenoxide and forms diphenoxide. In this way, the process continues and forms and undergo polymerization and forms the polycarbonate structure. In this way, approximately 1 billion kilograms of the polycarbonate is produced annually in this way. That means in this process. Coming to the uses of polycarbonates. Polycarbonates can be used in many ways because it is having a good electrical insulating property. It is used in the electronic industries, and it is also having the very heat resistant property, flame retardation property. It is also used for electrical and telecommunication hardwares. Electrical telecommunication hardwares, and it is also as a dielectric in high stability capacitor. So this is about the electronic components. It is used as a domestic wares, electronic insulators in the electronic industries, and other uses are it includes the greenhouse enclosures, automobile headlights, outdoor fixtures, and medical industry applications, though the list is virtually endless. And coming to it is also used as a construction material. Polycarbonates is used in the construction in industries for dome lights, gasoline and sound walls. And the major application of the polycarbonates is the production of the compact discs, DVDs. Due to having the low molecular weight and high impact and cracking resistance, polycarbonate is used for making automobile headlamp lenses and bulletproof glasses, windows in automobiles. The so-called Theft Pro plastic packaging for smaller items which cannot be opened by hand is made from polycarbonates. Laboratory safety goggles, sunglasses, computer cases, and printing substrates for nameplates, etc., are produced from polycarbonates. Coming to the properties of polycarbonates. Polycarbonates are durable material with high impact resistance and low scratch resistance. And these polycarbonates are stronger and hold up longer extreme temperature along with high transparency to visible light. Polycarbonate possess the glass transition temperature of about 147 degrees centigrade. And the polycarbonates are transparent and good electrical insulator, and it undergo plastic deformation without cracking or breaking. Hence, they can be processed and formed at room temperature using sheet metal techniques such as bending on a brick. So this is about the complete information about the structure, synthesis, properties, and the uses of polycarbonate. Coming to the another example, which is called polyurethane. This polyurethane, it is a class of compound called reaction polymer, which is made from diol alcohol and diisocyanate monomer. The isocyanate compound contains a functional group of OCON, isocyanate, whereas the cyanide contains only C triple bond N. This is the structure of the isocyanate. The rearrangement reaction leads to the formation of urethane linkage. This is the urethane linkage. Technically, this polyurethane is not a condensation polymer since no molecules are lost. In this, the no molecules are lost, but the functional groups rearrangement takes place. This is the ethylene glycol. It is having the diol structure, and it is having the diisocyanate, which is having, this is one isocyanate linkage and this is another isocyanate linkage. These two reactants or the substrates will undergo the reaction in such a way that the functional group gets rearranges itself and forms this urethane linkage. And this urethane contains epoxies, polyesters, and phenolic linkages. And it is a thermosetting polymer. It is composed of the organic unit joined by the urethane linkage and formed by reacting the di-R polyisocyanate with diol-R polyol in the presence of a catalyst like tertiary amines such as triethyl ethylene diamine and dimethyl ethanol amine. The surfactants such as the silicones, oils, and nonyl phenol ethoxylate are used during the foam formation. Coming to the properties of the polyurethane, this polyurethane possesses the excellent hardness, tensile strength, and impact resistance and abrasions and tear resistance, that is tear resistance. They resist the hard environmental factors such as heat, moisture, gases. They are highly resistant to chemicals, oils, and solvents. They possess the property of adsorption of heavy metals, coloring agents. Polyurethane exhibit good electrical insulating properties, and it has a wide range of materials like metal and wood. Hence, an ideal material for wheels, rollers, and inserts. They possess high flexibility and load-bearing capacity. They can be formed by blowing the carbon dioxide into the molten polyurethane. So these many properties are there for the polyurethane compound. Coming to the uses or applications of the polyurethane in which it is applied. These polyurethanes are found everywhere in the modern life. The chair you are sitting on, the bed you sleep in, the house you live in, the car you drive, and it is having an innumerable applications. Some of the important applications are production of foams like flexible foam, rigid foams, surface coating, and rubber. And it is also used as a building insulation, and it is used in the refrigerations and the freezers, and it is used in making the furnitures and the bedding articles, and it is also used in the footwears, automotives, coatings, and adhesives. Elastomers and the sealants also they are used. Polyurethanes are used in the purification of water and sewage for adsorption of coloring matter and heavy metals. And they are also fine used in the leather substitute. They are used to produce the gaskets and seals. So these are the properties of the polyurethane. So these are some of the compounds, that is a Bakelite, polycarbonate, and polyurethane structures, which is the best examples for the thermoplastic and thermoset plastic resins. Thank you.